This is the modeling cost and cost function. Um, uh, yeah. I'm going to read the question and then I'm going to have the question on my phone while I do it. So, yeah, for number one, it is saying a piano manufacturer has a daily fixed cost of $60 and a marginal cost of $2 per piano. This is telling me that the fixed cost, a cost that will always be there or that will always be the same, is the $60 and the marginal cost is $2. So every piano is to manufacture a piano, it costs $2 per piano. So it's telling me that the 2 depends on the X. The 2 needs to be changed by the number of pianos rather than the 60, where it does not have to be changed by the number of pianos. It is a fixed cost. So that's why for number one, I can see that it's asking me to find the cost C of X, and C of X can be seen as any function of X, just like in pre-calc when you did f of X, you can do C of X, you can do H of X. It's whatever is convenient for you to remember what this function means. So C, which is cost, I'm guessing it's the cost with respects to X, with respects to the number of pianos in a day. To find the cost of manufacturing X pianos in one day. So that's the first thing I'll do. For number one, when they're saying to find the cost C of X, it's not asking for an exact number. You're asked for a function. Especially this is the first hint that your answer should be a function. Um, it's that because C of X, X is the independent variable, and C is the dependent variable. So find the cost. And so if I am thinking about this, it's saying that a fixed cost of $60 plus per plus 2 times the number of pianos. That's what I'm thinking about. And it should make sense because if you were to calculate, let's say, if a person made 4 pianos a day and you want to calculate how much it costs to make 4 pianos, you would do the cost you would you would calculate the cost of the to facture a piano, which is $2, times the number of pianos, which was 4. However, given the information, we're given that the daily fixed cost is $60, which is why you add the 60, because that's kind of like the starting price, which is why this example can be modeled by a linear function. It would be similar to y equals mx plus b, where m is the slope and b is the intercept. But if you were to interpret it in the context of this question, m is the rate of price as it's going as the pianos increase. How much does one how much does manufacturing one extra piano do to the total cost? And it's represented by and B is the intercept, but it's also the starting rate. Because if you think about what an intercept is, it's when x is equal to 0 and y is equal to something. And if you were to look, if I were to say 60 is here, y is the y-intercept. It's without making any pianos at all, I still have to pay $60. That's what it's saying. So, which is why the function is c of x is equal to 2x plus 60. And this should make some intuitive sense as well. On number two, on a given day, what is the cost of what on a given day, what is the cost of manufacturing three pianos? So for this one, when it would be helpful to write down what you're given first. It says that you're given that you manufactured three pianos. And as we already know, C of X is cost, and X is number of pianos. So it should make sense that you just plug in 3 into the equation. 6 plus 60 equals 66. So at a given day, you make $66 from the piano if you were to sell 3 pianos. And then what is the cost of manufacturing the third piano that day? It is this question may seem more tricky, but it's asking the cost of manufacturing the third piano. So if you were to manufacture, this is how I'm approaching the question. If you were to manufacture two pianos versus three, what is that cost of the third piano? And I'm pretty sure that because the the number of the rate, the cost that the cost of the piano depends also on the number of pianos. You're not comparing like the 60 at all. You're just saying if I were to do one additional third piano, how much would that add to the cost? And well, we already know that the $60 is fixed, so you don't add that because there's no additional charge. So all you're looking at is the 2x. For example, you would do, if I did two pianos, let's say two pianos, and then three pianos, I would be plugging in 2 times 2 plus 60, and then 2 times 3 plus 60, and you would get 66. And then you would get 64. You're comparing the difference. You're not comparing like two pianos, like the full cost divided by two pianos. Rather, it's the difference. So it would be $2. And this should make sense as well because the only thing getting changed by the number of pianos is the 2x. And for number four, which is a similar question, what is the cost of manufacturing the 11th piano that day? The 11th piano is just the same as the third piano. You can think about it as comparing the 10 pianos or 11 pianos, I mean versus, but you can also just think about it if you're really strong on that definition. The only number that's really changing after you add that 11th piano is the $2. So this one would also be $2. This would go, the same would go for 60 pianos, the 200th piano. The only way that I could imagine that the question would change is how much is the cost of the second and third? In that case, you would just do 2 plus 2. Because how much extra does it cost to do the second and third? Yeah. And then um for number five, It's asking what is the variable cost, what is the fixed cost, what is the marginal cost. So I believe the variable cost is the cost that depends on the variable. I think that's how I interpret it. And in this case, it would be the 2 times x. The fixed cost, they already told you in the example, like the first part, it's $60. And then the marginal, which is how much does it cost to manufacture, I think, is or marginal cost. Yeah, it would be $2. Yeah. So for number 6, graph C as a function of x. This should be pretty easy since you did most of the work. There's many ways you could approach this. Me personally, I just like to use the line, but you could also use the coordinates that you got from this one. And yeah, so 2x plus 60, I would do 2x plus 60. So I would do maybe start from 60. And every time you're making a graph like this, you should set the scale to be increasing by the same. So if I go from 0 to 60, I have to go from 60 to 120, 120 to 180, and then I have to go from 180 to 240. Um, and then this should be the x, and then this is the y. This is just standard, but in this case, the y is c of x. And x is number of pianos. So you do 1, 2, 3, 4, 5, 6. Yeah. So my y-intercept is here. So I know that one of my points is 0, comma 60, but I don't really know any other points, but I do know the slope. So $60 and it increases by 2. So the next one would be kind of here. And then or not even there, it would be increasing really slowly. Um, but it's kind of it's linear function, so it kind of looks like this. Um, maybe I should have done a different scale, but I didn't really want to like make it really big. So if I were to do it again, maybe I would change this from I would do like 20. I would do 10, 20, 30, but then I would start graphing kind of up here. But this also works. This is totally fun. And even though it doesn't make sense, because it doesn't really make sense to have negative pianos, um, if you were to graph the rest of the line, it would be here. But typically, I think for these, it was not it because it's not realistic to um graph like negative the cost of having negative pianos. It would just it would be fine to just graph this part. Okay, so that's the first question. The second question, it is as of March 2015, Yellow Cab Chicago's rates amounted to $3.05 on entering the cab plus $1.80 for each mile. So the good thing about these examples is that it's pretty easy to figure out which is the kind of fixed cost versus I think it was the marginal cost. I'm not sure exactly on the the definition or the variable cost. Um, so because it says you can kind of imagine this. It's like when you enter cab, they charge you immediately just a flat fee of $3.05. And it should make sense because it's like if you ever take an Uber, it's they always it wouldn't be reasonable to take an Uber for like a a 2-minute ride because they have that fixed cost of the that Uber charges you, and then the additional costs as the number of the time of your trip increases. For example, if I were to take an Uber from my apartment to the supermarket, it might be $10, but the supermarket is only like 2 minutes away. So it doesn't really make sense to pay $10 to go. But then if I were to take an Uber to the airport, it would be maybe the $10 plus the amount of ti money per minute that I spent getting to the airport. And so, yeah, so that's makes some sense as to how to interpret the problem. It's $3.05 on entering the cab and $1.80 for each mile. So it's basically saying when you get into the cab, pay $3.05, and if you go travel 2 miles, this would change. But this is the number of dollars per mile. So we can do this problem. For number one, it's asking find the cost C of an X mile trip. So cost of my X mile trip. So if my trip, so my trip depends on the cost of X, and it's really similar to the first problem. So I'm just gonna say C of X again, because I think this would be this is going to be repeated, the C of X, because it's the C as in cost. I'm gonna say C of X is equal to that mx plus b, and then we can replace the variables. The C of X is equal to, I want to do the cost of um of each mile. As the miles increase, the costs also increase, and increase by how? $1.80, plus where X is the number of miles traveled in the trip, plus B, the fixed cost or the cost that you're charged upon entering the cab is $3.05. 3.05. So this is how to model it. For number two, use your answer to calculate the cost of a 40-mile trip. So 40 miles. The 40 miles, remember that X is number of miles, Y equals number O. Um, Cost represented by the dollar. So it would be it would be like this. 1 C of X is equal to 1.80 times the number of miles times 40 plus 3.05. And I'm not sure if you get a calculator, but I'm gonna use one. 1.8 times 40 plus 3.0. So the answer in dollars would be 75.05 for 40 miles. Okay, for number three, it's asking, what is the cost of the second mile? What is the cost of the 10th mile? So this question should look familiar as it kind of looks like numbers three and four on the first question. This is kind of a trick question. It's more an interpretation because the answer is actually pretty easy. It's asking how much extra would it be to drive for the trip to be an extra mile? That's basically the essence of the question. So from the second mile, you're saying how much extra does it cost from the first mile? So the first mile will cost something about like $5. The second mile is plus a certain amount. As we know already by interpreting this graph, I mean this function, this this is the only number that is changed by x. This does not get affected by x. So if I were to do an extra mile from the first mile to calculate the second mile, the only number that's getting changed is by the x or the variable cost, I'm guessing. So I would say the second mile would cost $1.80. 11th mile, if you want to guess, it also costs $1.80 because from the 11th mile, you're calculating it from the 10th mile. The 10th mile, the only difference is that you're adding that extra $1.80. So yeah, it should make some sense. And then for C, graph C as a function of x. Or number four. I don't know if I said number four. Or C, number C. This is my graph. This one would be helpful. I would say just do the increasing by dollar. I would say that's the hardest part is to determine the scale, but scale doesn't really matter as long as you can get the graph on there. This is the y, and once again, the y is our c of x. It's the same reason why when you have f of x, it's the same thing as they're the same. So, um, to graph it, you would start from if you were to travel 0 miles, but you still enter the cap, you'd be charged about $3.05. If you go 1 mile, you're increasing by $1.80, which is kind of here. I would say here. I'm kind of rounding $2. It's a $2, but a little less. This is the line of your function. Try to get a straight line like that. And oops, my bad. Usually you wouldn't graph the negative ones. 1, 2, 3, 4. You wouldn't graph the negative because it doesn't make sense to have travel negative lines unless you were to, I don't know. I'm not sure. I don't. which is why you don't draw a negative. And I see that's also what you did here. Oh, you also labeled, so I will also label. So this is number of pianos and cost in dollars, and then I also did it here. I think a lot of the times, if they're looking for some kind of labeling, they either want it would be clearer to them if you label the axes, but I think you can also get by with just writing C of x is equal to cos this because you're labeling this once again as C of x and x. Same thing here, but I'll label the y and x axis as well. Cost in dollars. Okay. So then number three. Number three is asking if the daily cost, including operation costs of manufacturing X t-shirts, when they give an X, it's kind of a hint that the variable or the marginal cost is coming next, but manufacturing X t-shirts is C of X. Oh, it gives you the whole thing. The C of X plus equals to 8x plus 100. Once again, a linear function. And the revenue obtained by selling X t-shirts is R of X. Then find the daily profit resulting from manufacturing and sale of X t-shirts. So basically, you want to find the profit. And I see that you gave those equations right here. Daily profit, find the daily profit resulting from the manufacturing and sale. Oh, I see. Okay. So I think pretty much this question is asking you to combine these two equations. So they're giving this is the cost. So it's like I sold, it's like I pay the company, I pay whoever makes my t-shirts $100 to manufacture as the flat fee. And then for every t-shirt, they charge me $8 per t-shirt. That's how you interpret this graph. This is what I'm paying to make the t-shirts. And then when I'm actually selling the t-shirts, it's like I'm not getting that fixed cost because it doesn't really make sense. It all depends on the number of t-shirts I sell. Like if I sold two t-shirts, it would just depend on this. There's not really a fixed, there's no fixed or like starting price that I receive because no one's really paying me that either. But anyways, find the daily profit resulting from the manufacture and the sale of X t-shirts. So you gave the equations revenue is equal to price times quantity. And it makes sense because if it's the price, so like $5 is the price times three sold. 5 times 3 is 15. So that's the revenue I receive. Profit is excluding the revenue, I mean, excluding the cost. I need to find that. So it pretty much makes sense. That's why it should make sense. But yeah, so find the daily profit resulting from the manufacturing sales of X t-shirts. So you would say, you would start by representing the revenue as P times Q. And then after that, you do P times Q minus, and then actually I'll do it this way. The revenue profit I'm gonna say revenue is equal to R, and so profit is equal to profit is equal to R minus C. And this makes sense because hopefully the R is bigger, so you never have a negative. It is also possible to have a negative R, obviously, which means you just lose money. Um, but in this case, I already know the R because R is P times Q. So profit is equal to P times Q minus 60. The cost. However, we're giving more information than that. The cost to make the t-shirts is 8x plus 100, while the revenue is 10x. So our goal in this question is to represent the daily profit with only one variable. Right now, I have one, two, and three variables. I don't want three variables. I only want one. I only want the X because I only know the X. I only know the amount of t-shirts, and I want to kind of relate the two equations. Well, profit is revenue minus cost. And so you can use this equation. So profit is equal to 10x minus the cost, 8x plus 100. And I put parentheses because eventually this will be distributed. In this case, it's just a minus c, but c is represented by something that by an equation that has more terms than just one, which is why the profit is equal to 10x minus 8x minus 100. So it's profit is equal to 2x minus 100. This is my profit. It should make sense. We can do, I'll do an example just to show you. So this is a t-shirt company. So I sold 5 t-shirts. I'm going to calculate it the long way and the short way, and I'll show you that they are the same. Calculate the so I'm going to calculate the profit number one using this equation, PQ minus C. So profit is kind of the idea because I'm still using these equations. So the profit is revenue minus cost. So the revenue is $10. So if I calculate revenue, cost, and by using these two functions right here is C and cost. Maybe I'll just use C and R. But revenue is 10 times the 5 t-shirts. The cost is 8 times 5 t-shirts plus 100. And once I get those numbers, I get 50, and I get 40 plus 100 is 140. Then, if I want to calculate the profit, I have my R and I have my C. My R is 50 and my cost is 140. This is kind of an example of losing money because your profit is you lost $90, it would be negative $90. You can say like loss dollars, or you can do negative 90. I think it would be like negative would go in front, but I'm not sure. But it would be lost. So this is an example of lost, but I'm saying that in theory, I would have the same, I would get the same answer with this equation, which is a simplified version. So if I used this equation, the 2x minus 100, 2x minus 100, I'm taking away all of these steps and just using this as my general profit equation. I do 2 times 5 minus 100. 10 minus 100 is again negative $90. And so it is the same answer. And the reason why that makes sense is because instead of doing all of these steps separately, I came up with a general equation. This is without a general equation, so you have to do r minus c. But in this case, this is already considering r minus c because I was given two formulas for r and c. It's kind of like simplifying a function. You remember, like, if you're given this, 3x squared plus 4x squared plus 9x, like that, you can simplify. The same thing here, I simplified the 8x plus 100 and 10x. So yeah, um, so that's the profit equation. It is 2x minus 100 profit. And then now what you're calculating next is find the daily profit resulting in from the manufacturer and sale of X t-shirts. Oh wait, my bad. Find the break-even point. Break-even point is basically when, like, for example, in this example where I did 5 t-shirts, I said that the break-even point, I would said that the person would break even at um oh, no, in this case, I said that they lost money if they just sell 5 T-shirts, they lost money. But the break-even point is asking, like, at what point do they neither gain money or lose money? It's kind of where their costs, where the money they earn or their profit is 0, actually. It's where the profit is 0. It's not negative, it's not positive, it's just 0. So that's what we're calculating. There's two ways, once again, to calculate this. As you can see from this equation, the profit is equal to R minus C. If you want the profit equal to 0, then R must equal to C. And it makes sense, R, and then you add minus C plus C plus C. I just added C on both sides so I can move it to either side. R must equal to C for it to equal 0. And it makes sense in this case, so we can figure it out. You have to say AX. I'm already using, and I'm using these, by the way. This is kind of the two formulas that I already labeled. I defined them as C and R, revenue and cost. And so if I want to say R is equal to C, I can just say 10x is equal to AX plus 100. So to solve, minus 8x on both sides, 2x is equal to 100, x is equal to 50. So this is the number of t-shirts that would allow me to have a profit of 0. And let's try it out. If I did 2x minus 100. And I'm trying it out, but I'm also this is equivalent to checking my answer in pre-calculus terms. 2 times 50 minus 100, and I should get 0. 100 minus 100 equals 0. And you see how that only works because 2 times 50 is equal to 100. The revenue has to be equal to the cost. Um, the next thing now is kind of kind of doing it the long way as well. Actually, yeah. I mean, this was the long way. This was the long way. The second way actually is because I know, I'm just gonna say, um, break even happens when profit equals to 0. And if I say I'm focusing on this idea here, profit is equal to 0. Right here, I'm using these two pieces of information separately. But I also remember that I came up with an equation earlier that gave the profit as a general equation. So instead of using 8x plus 100 and 10x, those two equations, I'm just going to use that profit equation that I came up with. So my profit equation is profit is equal to 2x plus 100. I mean minus 100, my bad. 2x minus 100. And if profit is equal to 0, in theory, I can take whatever step and I can use whichever equation. I can take whatever step and I would get the same answers. I would get the same answers as the long way. So I do 100. I just added 100 on both sides, then x equals 50. And if I look here, this is the same answer. And it's because the 2x minus 100 is only a simplified version of the long answer. It's nothing special, it's just simple. And yeah, so break even happens. But also, this is just for more of a connection to pre-calculus. If I'm saying that ax plus 100 and 10x, they have to be equal. That means that if I'm looking at it on a graph, I'm just gonna look at it just for fun. I'm gonna do 10, 20, 30. Oh, actually, wouldn't be good. I would do actually out of 50, 50, 100, 150, 200, 250, 300. Let me use this. So um, starting from 100 right here, it increases by 8. So it kind of looks like, and this is probably not accurate, not an accurate drawing at all, but this is my cost line. This is C of X. And if I were to graph our revenue or R, I start from 10, start from 0 and do 10. And it kind of look like this. This is kind of what it would look like, the line. Because as I'm noticing here, I'm comparing these two slopes. Even though the cost starts at 100, so it's getting a head start, the um the revenue would eventually catch up to it. And so where they are equal is the intersection point. If you learned about intersection points in pre-calculus, it was the system of equations. You're solving for when x and y are equal, and that's right here. So um, you would get the break even happens when the number of t-shirts is x. and it happens when um the number of t-shirts is X and the cost and revenue are equal. So let's just say I did just for just for another thing, just interesting. Just say cost, revenue. I'm gonna plug in the 50 into each of these equations. 8 times 50 plus 100, and then 10 times 50. This would be 500, and then this would be 400 plus 100 is equal to 500. So um, when the cost and revenue are equal to $500, my profit is equal to 0. This is just kind of breaking down the equations even more. This is obviously not that important, but it's just for a better understanding of a problem and how it relates back to what you learned in pre-calculus. Um, and then now I'm learning that this graph is not at all accurate because it would be more like here where 500 is at, their intersection would be more here, but doesn't the graph doesn't have to be that accurate. It just has to, because you are not asked to make a graph either. But yeah, okay. Finally, number 4. Um, after trying out a whiteboard for the first time, you figure out the secret of how to produce. You can produce 5 whiteboards in a month at a total cost of 45,000, and 10 whiteboards in a month at a cost of 70,000. You charge you charge money. I mean 10,000 per whiteboard. So this form might look familiar. You can produce, so it's telling you two different things. And you're and the most important thing to remember here is that these can both be represented by the same function. So after trying out a flatboard for the first time, you figure out the secret how to produce them. So it's because you are producing them, these are under the same conditions. So these two numbers, so the 5 flyboards in a month at a cost of 45,000 and 10 flyboards a month at a cost of 70,000 can be seen as coordinates. So 5, where X is number of flyboards and Y is cost to produce um each flyboard. So the first question is asking find your cost function. So again, I'm going to do C of X equals to mx plus b because they also told me assuming it's linear. If it's not linear, then you can't use mx plus b, but it says assuming it's linear. So find the cost function. Remember, in pre-calculus, when you're given 2 points, so in this case, I was given 545, 545,000 and 10, 70,000. When you're given 2 points, you automatically know if you were wanting to solve it and turn it into a linear formula, all you need is 2 points actually to figure that out. Um, you would use slope slope formula, which is y2 minus y1 equals x2 minus x1. And then you could use the uh, y equals mx plus b, but I would rather just use y minus y1 equals m times x minus x1 because it's just easier. And it eventually simplified down to this as well. I'll show you how. So yeah. And then another thing is is that typically when when you're talking about financial things, they're gonna give you really, really huge numbers. And the bigger the number, the higher the chance that you have a calculation error. So to avoid that as well, say, you could just define X as number of flyboards and Y as cost dot let me say you could do cost in thousands. And this makes sense because if I could say either 45,000 and versus 45,000. So for this one, it would be more x is x equals number of flyboard and y equals cost dollars. So it's counting every single dollar. But especially when you have a bunch of zeros, there's not really a point, especially when you can just say it in thousands. You just say 45,000. So instead, my coordinates would look like this: 45 and 10 and 70. So I'm saying five flyboards for 45,000 and 10 flyboards for 70,000. It's the same thing as this. But yeah, it's just a little easier and you could do it either way. But to continue on with the problem, I want to use the slope formula. So my y1, y2, I mean, oops, y1, y2, x1, x2. Remember, it doesn't really matter to which one you label as x1, x2, or y1, y2. You just have to keep it consistent. Like this has to be with the one. So x1, y1, x2, y2. The same coordinate has to be the first or the second. So I do 70 minus 45 and 10 minus 5, which is 25 over 5. I'm pretty sure. Yeah, it is, which is 5. So that's my slope. And the most difficult part about using this thousands instead of just dollars is that then you have to keep it really, really consistent. You have to label every unit as thousands dollars. So if I then this is my n. So I do y minus y1. I'm gonna use any formula. I prefer the smaller one, the 40. Actually, no, I prefer the 70, I would think. Because the 70, even though it's bigger, it's a nicer number than 45. So 7y minus 75 times x minus 10. And this should kind of look familiar, but if it's not familiar, basically you just do the y remains a constant because eventually it will be the same thing as this y. And then y1 is a coordinate on the line, and x1 is a coordinate on the line, and then m is the slope. That's how you basically plug it in. So I do y minus 70 equals to 5 times x minus 10, and it has to be from the same coordinate. This is my equation, and then I will solve for it. Y minus 70 equals 5x minus 50. Y equals 5x plus 20. So this is my final equation, 5x plus 20. I think, I think if you were to use the bigger coordinates, it would be like y equals um 5x plus 20,000, I think. I'm pretty sure that's what it would be. So you can double check if you use that one instead. So this is my answer for number one. I'll put it in a blue box to see. Next is number two. It's asking, what is the monthly fixed cost? Monthly fixed cost. It would be 20. I think I looked off at the number four, part two, number two. So that question is basically asking, what is the monthly fixed cost? Monthly fixed cost. So the monthly fixed cost, if you remember for the last few problems, and the monthly fixed cost was the cost that never changes. It's kind of like for the cab driver, or the cab price, it's the starting value. For example, in that cab example, it was $3.05. So the monthly fixed price is essentially the y-intercept in a linear function. In this case, we came up with a linear function ourselves that's representative of the relationship between the number of flyboards and the cost that it takes to make each flyboard. For example, it took to make 5 flyboards, it took $45,000, and for 10 flyboards, it took 70,000. But that is representative of the cost. It's the money I have to put in to make it. And so that is the function you would be looking at when you're answering the second question. The monthly fixed cost then would just be looking at this equation and remembering that this equation is with units of that in thousands, which is why I was able to only have 20. If I just did it by each dollar, it would be 5,000x plus 20,000x. I mean 20,000. So the monthly fixed cost would be $20,000. And it is really windy, so hopefully the audio will come through. But yeah, $20,000, or in this case, it might be more appropriate to write thousands because that is the unit, but it means the same thing. So that's a monthly fixed cost. The next problem asks, what is your revenue function? So if you remember from one of the questions, revenue was the price times the quantity. And it should make some sense because it's like the price you earn times the quantity of um times the quantity of items you sell. So the revenue function is actually going to be the amount of money we make. So it's has nothing to do with cost really. So you would have to look in the word problem, and it should give you more information. It says you charge $10,000 per flyboard, and that is the revenue. And so if it's $10,000 per flyboard, $10,000 per by 4. Well, I want to stay consistent with how I've been labeling these. So instead of saying 10,000, writing that out, I'm just going to say 10,000. So I can use the 10 instead of 10,000. It's just to make it more simple. But you would just do the price, which is 10, times the quantity. The quantity will be represented by the number of boards, and earlier we said it was X, so 10 times X. So the revenue equation is R equals 10 times X, or R equals P times Q if you're using the actual definition of the equation. And then for the next one, number 4, what's your, oh wait, did I do marginal cost? Oh, oops. I accidentally skipped marginal cost, so I'm just going to switch those two. Marginal cost should also be pretty simple, especially when we're just given this really easy mx plus b formula, y equals 5x plus 20. It should follow the same pattern that the marginal cost is always a number that is with the x. So in this case, it would be 5,000. 5,000 dollars. And then it's the 5,000. Once again, even though it says 5, I said 5,000 because I set my y as cost in thousands. So I'm counting by thousands. That's what it means basically. Okay, so switch these. This should be 3. This should be 4. And then for number 5, what's your profit function? So you have to remember that profit, revenue, and cost are all different things. But profit is the one that counts in the cost and the revenue. So it's counting the revenue I made and the cost that I spent. So the equation for profit is P equals, I'm going to say P, I'm just going to write out profit because I think I have another P. Profit is equal to R minus C, revenue minus cost. I know that I have 2 equations already. Y, again, it might be confusing. Y is the same thing as C of X. So I'm just going to say instead of Y equals 5X plus 20, I'm going to say C of X equals 5X plus 20. And so this is the cost. I already have both of my equations. I just need to plug it in. I'm going to lay it out so it's all in front of us, but R is equal to 10 times X, and C is equal to 5X plus 20. So we look here, profit is equal to 10X minus, and the parentheses are essential in this case, 5X plus 20. I noticed here how it was good that I stayed consistent with, instead of writing 10,000 or 10,005, I had to stay consistent because my units are in thousands again. So instead, this is 10,000, this is 5,000, this is 20,000. So profit is equal to 10x minus 5x minus 20. So my profit function, after combining the revenue and cost or subtracting them, I get 5x minus 20. So it's pretty similar to the actual one, except for the fact that it is subtracting the 20,000. But if I wanted to put units back into dollars, instead of just thousands, I would do profit is equal to 5,000 x minus 20,000. And so, yeah, the and then number 6, what the break-even point. Once again, as I showed you earlier, the break-even point is a direct application of what you learned in pre-calculus, or I don't remember if it's pre-calculus or algebra, but it's a application of what it actually means to do a system of equations when you're solving for two variables with you're given two functions. The break-even point is considering the revenue and cost as two separate functions. And you're thinking about when these two functions intersect, because it's basically saying that when you do R minus C, which is P, profit, it has to be 0 because you're neither gaining money nor losing money. But the good thing is that there's a shorter way to do it after we have the general equation of profit. Because we have this equation, which counts in the revenue and the cost both into one equation, you can just set this one equal to 0. But if you noticed from the last problem, you could do it two different ways and you would get the same answer. But this one just seems easier. So I'm just going to use this one just because it's where I ended up. 0 equals 5,000x minus 20,000. So add 20,000 on both sides is equal to 5,000 times x. And x would equal to 5,000, 5,000. You can cancel the zeros, it would be equal to 4. So to break even, that means to break even, one must sell 4 fly boards. And just as a representation of this, or what it even looks like, even though it's like you're graphing here when y goes to 0. So it's like here, let's say 20,000 is like here, 20,000 is here, and or negative 20,000, and you're slowly going up until you get to 5,000, until you get to that intersection. I would think that the slope kind of looks like this, but you're looking for this point of the profit where it's breaking even, because right about here, you're still losing money, money because the profit is negative. But right when you hit here, you are gaining money because the profit is positive. Another way to look at it is if I graphed the cost and revenue function. The cost is how much I spend, the revenue is how much I earn. Let's say this is the revenue. I'll call revenue R of X. This is the revenue. And let's say this is the cost. There's a point here where you are earning and spending the same exact amount, which makes your profit 0, and that is the point you're looking for. That's why if you used R equals 10x and C equals 5x plus 20 and solve for x, when R equals C, you would get your break-even point. And you could also find out how much how much money spent and received would give you the break-even point. For example, you must make you must make 4 flyboards, but you'll get $40,000, and you will also be spending 40,000 to make the flyboards. Yeah. I think that's the last of questions. If you have any questions, let me know. But yeah.